Urban Electric Power is focused on developing a new chemistry.
We want to make a battery product that's economical, safe, and viable across all different applications for storage.
So it's similar to a Duracell.
The difference is we figured out how to make these batteries discharge and charge for many, many, many cycles.
In other words, that would equate to 5 to 10 years of life.
So we have a cell, which is about this big, and then we combine these cells in series and in parallel to build systems that are larger and larger.
So here in the lab, we make everything from the electrodes, the electrolyte, and all the components that go into building a finished product.
The chemistry is benign. The materials are abundant. There's always a constraint on the raw materials with respect to lithium or cobalt, which is what's used in lithium ions. And our risk of explosion or fire is dramatically reduced simply because our electrolyte is water-based rather than organic.
Our goal here is to be economically friendly, much more friendly than lead acid. There's no lead, there's no mercury in these batteries. It's cheaper.
In New York, the transmission and distribution network is very maxed out. So even if we had more generation, we couldn't get that generation to the end user. So if you are a large commercial building or a large university campus, for instance, you could have a battery in your facility, store energy at night when we're not using it, and then during the day, dispatch that battery during the peak period, therefore reducing your overall demand during the peak time.
In the US, we enjoy a very stable grid. That is not the case for the majority of the rest of the world.
They lose electricity in the morning, and they might lose again electricity in the afternoon, and then lose again electricity at night.
There's basically a box. It's an appliance. It's an inverter. It takes electricity off the grid when it's available. It charges a battery. When the grid actually loses power, then the inverter takes the electricity that was stored in the battery and dispatches it to the consumer.
A traditional backup system based on lead-acid batteries needs 10 hours to be charged. Our batteries can be produced at the same cost of lead-acid, but customers to charge them in 2 to 4 hours.
It is on-demand use of energy to support the very basic needs in your household for those 2, 3, 4 hours that you don't have electrical grid available to you.
So the application of our technology for developing countries is one that will allow every household in India to charge their batteries fast so that they can serve the multiple blackouts that they have during the day.
And so it is a way that actual developing countries are able to increase their social level relative to some of the developed countries.
In addition to smaller UPS systems for developing nations and peak shaving systems to serve New York and the greater US, here at UEP, we are also developing large utility to grid-scale size systems for bulk energy storage. This will enable utilities to time shift energy and balance supply and load, offer improved power quality and reliability, and most importantly to UEP's strategy, allow large adoption of intermittent renewable sources onto the grid, like solar and wind.